Hi everyone, my name is Moses. I created a model that turns outlines into stylish and colorful icons. Icon and logo design is difficult. Expert human designers choose from line weights, colors, textures, and shapes to create beautiful icons such as these. But there seems to be some pattern to how designers make their choices. Can a computer learn this? I decided it would be quite interesting to try and train a model that learns the designer's style and then takes any freely available icon outlines, such as these from the Noun project, and color them in exactly like the designer would have, but completely automatically. Here's a quick demo of what I achieved. Let's use icons that the model has never seen before. This is an icon pack that went viral on Product Hunt. Let's say our side project is for sharing beautiful royalty-free images. So we go to the icon set and then we find an icon that we like this camera. We then download it, and then feed it through our model. Now the model inference actually only takes half a second, but loading in the model with all its parameters takes a while. And there we have it, voila! A fully colored and stylized icon, with good use of darker shades of orange to give the icon some visual depth, and this splash of green to make it really pop. Now what approach did I take? I modeled this as a supervised learning problem. There are more details in the report and poster, but at a high level, my model takes in a 1 by 128 by 128 grayscale icon and produces a 3 by 128 by 128 RGB icon, which is compared to a true RGB icon using some loss function. The model that I used was a convolutional neural network called a UNet, and it was trained on an icon set from Smash Icons. I taught my model to convert outlines such as these to yellow style icons such as these. But this approach can be used for arbitrary styles because I didn't hard-code anything. Now in terms of experiments, I first tried using the per pixel L1 loss as the solitary loss function, which worked really well on in-sample validation set icons. But I found it didn't do so well on validation icons and out-of-sample icons that had dramatically different scales or outline styles. The model really struggles on out-of-sample icons, where the lines are much thinner than those from Smash Icons. Now to improve generalization, I created a data augmentation pipeline to rescale, reposition, blur, sharpen the lines of inputs, and add noise to the data so that the model is invariant to all of these. You can check out the ablative analysis that I did to see which of these augmentations were most helpful. With this, validation and out-of-sample performance were much better. However, the model was still creating icons that were overly yellow, as you can see in figure 2. This makes sense since the L1 loss discourages the model from predicting underrepresented colors such as blue and green. To tackle this, I trained a discriminator under a conditional GAN setup and made the generator minimize both L1 and adversarial loss. This improved color reproduction and is the final model that you saw in action. I ran many more experiments, especially with architectures and non-linearities, but this is all the time and space that I have to present. In terms of next steps, we can view user hints and adversarial loss as two different ways to force the model to make up its mind in ambiguous color situations. So my next step is to explore incorporating user hints to resolve color ambiguity. You can download the demo from the link below. Thanks for checking this out.